speculative decoding has quietly become the most important inference optimization nobody outside the infra teams talks about, and the Eagle team just patched its most embarrassing failure mode. Quick refresher, because this matters more than the name suggests. Speculative decoding is the trick that lets a large language model generate text 2 to 3 times faster without changing its outputs. A small draft model proposes a sequence of tokens. The large target model verifies all of them in a single parallel pass, and any tokens the target would have produced anyway get accepted for free. You get the exact same final text, just at a fraction of the wall clock cost. The economics only work because GPU memory bandwidth, not compute, is the bottleneck for autoregressive generation. It is now the default fast path in essentially every modern inference engine. vLLM ships it. TensorRT-LLM ships it. SGLang ships it. Anthropic, OpenAI, and Google have all confirmed they use some variant of it internally. If you have noticed that token streaming from your favorite chatbot feels noticeably snappier than it did 18 months ago, speculative decoding is a big part of why. The trick has gone from research paper to load-bearing infrastructure in under 3 years. And inference, not training, is now where the money actually goes. A frontier model gets trained once, but serves trillions of tokens. Even a 15% speed-up translates to 9-figure savings at hyperscaler volume, and to existential cost differences for smaller providers running on rented GPUs. That is why every major lab is fighting over draft model architectures, verification kernels, and tree-style speculation. This stopped being a research curiosity the moment frontier providers started losing money on every long query. Eagle itself is the speculative decoding method that won the open-source benchmark wars over the last 2 years. The original paper proposed running a tiny draft head directly on top of the target model's hidden states, rather than training a separate small model from scratch. Eagle, 2 added dynamic draft trees that branch into multiple candidate continuations and pick the best one. Eagle, 3 reworked how those hidden states get reused across speculation rounds. Each version pushed acceptance rates higher and end-to-end latency lower, and each became the new baseline that other methods had to beat. But the family had a known weakness, and it is the one Eagle 3.1 explicitly targets. The MarkTechPost piece calls it attention drift. The short version is this. As the speculative draft window grows longer, the attention distribution the draft head computes starts to diverge from what the full target model would have produced at those same positions. You are effectively predicting tokens from an increasingly stale view of the context. In practice, this means the longer your speculation chain, the more drafts get rejected. Acceptance rates that look beautiful on a 4-token window collapse on a 12-token window. That is a real problem because reasoning models, code completion, and any long-form generation benefit most from deep speculation. Exactly the workloads where the drift is worst are the ones where you most need the speed up. The bug got more painful as the industry shifted toward longer outputs. Eagle 3.1 is the joint release that claims to fix this. The post is light on technical specifics, so I'm going to be honest about what is actually in the MarkTechPost article versus what we would need the paper or the repository to confirm. The headline claim is a structural change to how the draft head consumes attention state, designed specifically to keep drift bounded as the speculation depth increases. The collaboration is the more interesting signal. Eagle 3.1 is not just a paper drop. It is released jointly with vLLM, which is the inference server most of the open-source ecosystem actually runs on. That means it ships as a production integration, not a research artifact. If you're serving Llama, Quinn, DeepSeek, or any open-weight model on vLLM, this will land in your stack within a release cycle. TorchSpec is the 3rd name on the announcement, and the one most viewers will not know yet. It is a PyTorch-aligned speculative decoding framework that has been picking up momentum as the ecosystem standardizes around composable draft strategies. Having TorchSpec involved means Eagle 3.1 is not locked to vLLM. The same fix should flow into anything built on PyTorch's native serving primitives. Read the room here. Three previously separate efforts, the Eagle research line, the vLLM serving stack, and the TorchSpec framework, coordinated a single release. That is a different posture than what open source did even a year ago, when each project shipped on its own clock and integrators were left to glue the pieces together. The cost pressure on inference is high enough that the open ecosystem is now operating more like a coordinated supply chain. Who wins? First, and most obviously, any company running open-weight LLMs at scale on vLLM gets a free latency improvement on the workloads where they were most exposed. Long context retrieval, long-chain reasoning, code generation. If you're paying GPU bills for these, this is the kind of release where you just upgrade and check the dashboards. Second winner, providers serving reasoning models. The DeepSeek, R1-style architectures, the open analogs of the O series, anything that generates long internal chains of thought before producing a final answer. These models can spend thousands of tokens reasoning per query, and speculation acceptance rates were degrading exactly where the volume is highest. Fixing drift moves the cost curve in a direction that makes reasoning-heavy serving viable for smaller players, not just the hyperscalers who can absorb inefficiency. It is harder to name clean losers. Closed-source providers like OpenAI and Anthropic almost certainly have internal speculative decoding that is at least as good, possibly better. They are not disadvantaged by Eagle 3.1 in an absolute sense, but the gap between what hyperscalers have privately and what anyone can run on vLLM just narrowed again. That has been the broader story of the last 18 months, and this is another data point on the same trend line. Open source is not catching up uniformly, but it is catching up where it matters. Why do not know, and what I want to flag rather than fake. The MarkTechPost piece does not publish specific acceptance rate numbers, does not quantify the speed-up over Eagle 3, and does not detail the architectural change. Those will be in the paper and the repository. If you're making procurement decisions, wait for the benchmarks on your actual workload. If you're an infra engineer, the upgrade path is more interesting than the marketing number. What to watch from here? First, whether SGLang, TensorRT-LLM, and Hugging Face text generation inference adopt the same fix or ship competing answers. The vLLM and Eagle coordination is impressive, but the broader serving ecosystem is not unified. A fragmented response would slow real-world adoption considerably. Second, whether the drift fix unlocks meaningfully deeper speculation than was previously practical. If you can reliably accept 8 or 12 drafted tokens instead of 3 or 4, the throughput math changes substantially. That would have downstream effects on batching strategies, KV cache sizing, and how providers price long context queries. The shape of inference workloads changes when speculation depth doubles. Third, and this is the longer arc, whether reasoning model serving becomes cheap enough that the test time compute paradigm scales beyond the labs that can absorb the costs. Right now, inference cost is the binding constraint on how aggressively any company can deploy chain-of-thought heavy products. Every speculation improvement chips away at that constraint. The deeper takeaway is not Eagle 3.1 itself. It is that inference optimization has matured from a research game into something that looks like coordinated industrial engineering, with releases timed across multiple major open-source projects. That is what the closed-source labs have had internally for years. The open ecosystem catching up to that operating model is, frankly, the more important story than any single algorithmic improvement. Watch this pattern. The next coordinated drop will tell you more about where open inference is going than any single benchmark number.